Here's an answer key for the position and total distance assignment. On the front page, our first problem, we're given the velocity of a particle to be the sine of pi over 4t. This is valid for the domain from 0 to 8 for t, and at time t equals 0, the particle is 3 units to the right of the origin. So question A asks, when is the particle moving to the left? Particle is moving to the left when the velocity of the particle is negative. So we have to figure out when the sine of pi over 4t is less than 0. So for starters, let's figure out when the sine of pi over 4t is equal to 0. Right? So the sine of pi over 4t needs to be equal to 0. Now the sine of 0, or rather the sine of x in general is equal to 0. We can write that over here. Sine of x equals 0 at x equals 0, and then again at x equals pi, and then again at x equals 2 pi. So we basically need to know, when does pi over 4t equal 0? Well, that's when t is 0. And we need to know when pi over 4t is equal to pi, and that's going to be t equals to 4. And then when pi over 4t is equal to 2 pi. Multiply by 4 and divide by pi, and we get t is equal to 8. So those are our three values when the velocity is equal to 0. So we throw those on a number line, and we don't really need to worry about 0 and 8 because those are our endpoints. We're really just looking at 4. And now we're going to pick a value to the left and to the right. So let's pick some even numbers here. So we've got 2 and we got 6. If t is 2, plug 2 into our velocity. 2 times pi over 4 is pi over 2. The sine of pi over 2 is 1. 1 is positive. And if t is 6, put 6 in right there. 6 times pi over 4, well, 6 and the 4 reduce or simplify down to 3/2. So we have the sine of 3 pi over 2, which is negative 1. So our velocity function is negative after 4. And we know that the particle is moving to the left when the velocity is negative, so that's going to be from 4 to 8. Right, but do not evaluate an integral expression that gives the total distance traveled by the particle from time t equals 0 to time t equals 4. Okay, actually let me scroll up just a touch here. There we go. Alright, and in doing so, total distance we know is integral from a to b, 0 to 4, of the absolute value of our velocity function. And our velocity function is defined to be sine of pi over 4t. We don't have to write sine of pi over 4t here, but we could. But ultimately, you need the absolute value markers. For part C, write but do not evaluate an integral expression that gives the net distance. Right? So net distance is the same thing without the absolute value marks. So integral from 0 to 8 this time, because that's our bound. And we just have v of t dt. Right? We just have to write it. We don't have to evaluate it. Find the acceleration of the particle at time t. Acceleration is equal to the derivative of velocity. So we know velocity is the sine of pi over 4t. So acceleration will be the derivative of that. And, oops, there we go. And so we have the derivative of sine. We have chain rule going on here because we have the sine of an inner function. So the derivative of sine is cosine. And then we keep the inner function, pi over 4, t. And then we multiply by the derivative of the inner function. And the derivative of pi over 4t is just pi over 4, which you can throw at the end, or we can throw at the beginning. So we have pi over 4 cosine pi over 4t. That's our acceleration at any time t. For question E, we're asked whether the speed of the particle is increasing or decreasing at time t equals 2. Well, we have to look at the velocity at 2 and the acceleration at 2. The velocity of the particle at 2 is greater than 0, but the acceleration, which if we plug in 2 we get this, is equal to 0, which is not what I wanted. So we're going to just ignore this problem. You can move on right to part F. And if we do so, find the position of the particle at time t equals 2. Okay, so the velocity, the position, right, that's our x of t, so x of t is equal to an initial position, x of a, plus the integral from a until whenever, t value, of our change in position. And our change in position is our net distance, so that covered, so that's our velocity in the integrand. Okay, so we were told at the very beginning that the particle, if you look up at the top of the page, that the particle is at position 3 at time t equals 0. Okay, so we know that we're starting with an initial position of 3, and that happens at 0. So put the 0 as our low bound and the 3 as our constant that we're adding. We're interested in our position at time t equals 2. So we want x of 2. So this 2 becomes our upper bound. So we're going to have 3 where our particle started, its initial position, plus all the change from the time that we started looking, which is 0, till the time that we're interested, which is 2, of our velocity. So we got sine of pi over 4 t dt. And it says show the work that leads to your conclusion here. So we've got our work cut out for us here. We can see that we have the sign of something ugly. So if our u, if you will, is pi over 4 t, and the derivative of pi over 4 t is pi over 4, which we don't have out front, so we need a pi over 4 out front and a 4 over pi in outside of the integrand. Now, this will behave just like sine of x. In other words, we don't need to change our bound anymore because we placed in the extra coefficient. So we've got 3 plus 4 over pi, and now it's time to take our antiderivative. The antiderivative of sine is going to be negative cosine. So we're going to have negative cosine. So we're going to make the 4 negative, and we have cosine pi over 4t. And that's being evaluated from 0 to 2. Alright, so now we can punch in our values here. So we have 3 minus 4 over pi, and that's going to get multiplied by the cosine. We plug in the 2 first. So the cosine, 2 plugged in for t, twice pi over 4 is pi over 2, minus, now we plug in the 0. The cosine is 0. Okay, so make our factor bar a little better there. Cosine of pi over 2 is equal to 0. Cosine of 0 is equal to 1. So we have 3 minus 4 over pi, and then we have 0 minus 1. And we're in the corner of the paper, so we'll go up here. 0 minus 1 is negative 1, times negative 4 over pi means we have 3 plus 4 over pi as our new position at time t equals 2.